You've probably seen optional on the slides I've shown you on terminal operations. Optional is a generic class whose purpose is to be a container for a value which may or may not be null. It was created by Java's engineers to address the problem of the null pointer exception, which is one of the most common errors in Java. The Java documentation says this type is primarily intended for use as a method return type under specific conditions. Optional tries to solve the problem of when no result or no data is a perfectly valid situation versus when no result might really be an error. You can think of many situations where no data makes sense. Not everyone has a middle initial in their name, or even a last name for that matter. No data for a birth date may or may not be an exception. For genealogy applications, it may not yet be known, but for employment, it's required. New inventory may not yet have a sales price. Using a $0 price as a default, rather than no price, could lead to problems. These are just a few examples where no value isn't necessarily an actual exception or error. Optional is a way of indicating that a value may not be present and can therefore be safely ignored during processing. Optional is just another generic class, so you declare it like any other type with type arguments, but you don't construct an optional. Instead, you use one of the static factory methods as shown below. These methods are empty, of and of nullable. This will probably make a lot more sense if you see how it looks in code, so let's get back to that. I'll be working with the Streaming Students project again. I'll create another class with a main method. This one I'll call main optional. I'm going to copy some code from the main collect class, specifically lines 14 through 20. I'll paste these lines into main optional's main method. I'll change toList to the collect operation instead because I plan to make modifications to the list. I'll next add a private static method to this class. This method will return an optional with a type argument of student. It will take a list of students as well as a string for the type of retrieval, which can be first, last, or any. If the list is null or empty, I'll return null. If the argument type has the value first, I'll return optional.of, passing that the first element in the list. Similar to above, but if the argument value passed was last, I'll return optional.of with the last element in the list. If the argument value is anything else, I'll pick a random element and pass that back to a call to optional.of. I'm going to ignore Java's warning on null there for the moment. Getting back to the main method, I'll test this method out. First, I'll set up an optional variable, O1, and assign it the value I get back from invoking my getStudent method, passing null for the student list, and first as the type. I'll execute two methods, isEmpty and isPresent, on what gets returned back, and I'll then print it out. If I run this code now, lo and behold, I get a null pointer exception even though I'm using optional. Didn't I just say the optional is intended to solve problems like this? Well, it turns out that optional is only as good as the developer coding the methods. The first rule for developers who use optional is that any method that returns an optional should never return null. Instead, it should return an empty optional. IntelliJ had flagged a warning for me on my getStudent method, and if I hover over that, the message is null is used for optional type in return statement. The solution is an easy one. I'll make the change in my method and simply return optional.empty rather than null. If I run that code now, I see the isEmpty method return true and the isPresent method return false, and the optional I get back is empty. I'll be talking more about how to use optional shortly, but for now I want to explore optional creation a little longer. I'll test my code by passing an empty array list instead. Running this code, I get the same result as before, so that's good. I'll copy these 3 lines of code and paste that just below. I'll change O1 to O2, and this time I'll pass my students list in. I'll change O1 to O2 in the println statements as well. Running this now to see what we get. I now get the opposite result for this instance, that empty is false and present is true. I've also got a student in the optional container. But what happens if one of my list elements is null? I'll add null to the beginning of my list, so I'll pass position 0 to the students.add method and null as the value. Running this code, I get another null pointer exception coming from line 38 in my method. As it turns out, you can't create an optional using the of method and pass it a null value, which is what is happening here. Instead, I have to use the ofnullable method, so let me change the 3 places where I use the of method, changing it to ofnullable in each case. Running this code with these changes, I'll get an empty optional back. I'll remove that line of code that adds a null value to students. If I run that, I can see in the second case that the optional isn't empty and has a value as student, but how do I go about accessing it? The optional type has a get method, as you might expect. Let's see what happens if I use it in both these cases. I'll add a println statement after each of the code blocks, passing a 1.get in the first case and o2.get in the second one. I'll move the o2.get to the right place on line 30. I'll ignore IntelliJ's warnings and run this. I'm getting an exception, this time on line 25, where I called a 1.get. It turns out that you can only call the get method without getting this kind of exception if isPresent is true. I'll comment this line out. Running the code now. I see that I do get the actual student printed when I call o2.get. But what does this warning from IntelliJ say? If I hover over that, I see the message optional.get without isPresent check. That means I'm calling get before checking the result of the method isPresent. I can fix this if I wrap that call in an if block, first checking that isPresent is true. One warning goes away and another appears. This time IntelliJ wants to tell me something about this conditional expression. This code can be replaced with a single expression in functional style. I'll pick the option below that message, replace optional presence condition with functional style expression. IntelliJ replaces that if statement block with a single call to an if present method on the optional instance. This method takes a consumer, so I can pass the usual println method reference. I get the same output as before. What happens if I copy that statement and paste a copy on line 26? I'll change O2 to O1. Running this now. It's a little harder to see, but I don't get any output from that call, and that's because that optional is empty. It didn't throw an exception though. There isn't an if-empty method on optional, but there is an if-present or else. So I'll change that first call to that. That gives me an error at the moment. I'll click on that method, then Control-click to bring up that particular method's code. Here you can see this method takes a second parameter, a runnable called empty action. I haven't yet covered runnable, but let's follow the trail, so I'll Control-click on runnable. Here you can see it's another functional interface, so it's a target for Lambda expressions. It doesn't take any parameters, and it doesn't return any. Getting back to my code, I'll simply add a Lambda that prints some text. I'll just print an arrow and the word empty. Running this. You can see that this empty was printed on the third line of output. This method lets you have a single call, whether optional is empty or not, which helps promote consistent, concise, and more readable code. The if-present and if-present or else methods provide a means for doing something with your optional instance. They aren't used to retrieve the value from optional or assign it to another local variable like the simple get method does. We can still use get, as I've shown you, preferably with a test of the isPresent method. Let me show you a slightly different version. I'll use a ternary operator to test isPresent, and if true, I'll assign the value of first student to the value in the optional instance, otherwise I'll assign that null. Now let's say I'm interested in the student's ID, so I'll retrieve that, but I'm back having to check for nulls here. I'll print the ID out. I can run this as the code is written. And I get the output. First student's ID is 1. IntelliJ again is warning me or prompting me to consider the way I've written this code. If I hover over that highlighted code, IntelliJ tells me I can replace this with a functional style expression, so I'll select that link on this pop-up. That changes my code from the ternary to instead use a method called or else. I'll remove the enclosing parentheses since they were there to make the ternary easier to read. This is a special kind of get that will get the value, but if the value isn't present, I can specify another default value, in this case null. Let's say I don't want to return a null student as the other value, but maybe some dummy variable. For this, I'm going to create a quick, private static method that will return a dummy or fake student instance. I need a parameter for courses because my student constructor requires it, and I'm going to print out that I'm in this method getting a dummy student. I'll return a mocked-up student instance. Now I'll change my code, and instead of returning null, I'll return the dummy instance. Notice that there's a warning on the next line on the expression first student equals null. IntelliJ has figured out that null is never going to be a valid option. I'll hover over that and select the simplify option there. If I run this code, it works the same, but with a notable difference. Even though my optional instance has a value, a valid student, I see that the call to get dummy student was made. If I pass a method invocation as an argument, as I'm doing in this code, that method gets called, whether I need that value or not. If you're processing data in a stream using an optional, this could impact performance greatly. The better alternative in most cases is to use the or-else-get method, whose parameter is a target for a Lambda expression. I'll change my code to use that instead. I'll comment out the original or-else statement. I'll again set up my first student local variable and assign it to a method on my O2 instance. This time I'll call or-else-get. This method takes a supplier, so I'll pass a Lambda expression which calls the getDummyStudent method, passing JMC. Now if I run this code, I don't get the message getting the dummy student. The Lambda expression's functional method doesn't get invoked unless the optional is empty. If I control-click that method and scroll up a tiny bit, I can see both the or-else and the or-else-get methods together on this screen. Looking at these together hopefully makes it more obvious to you why that first one is executing getDummyStudent in either case. The or-else-get method uses a ternary operator, so when one condition is met, any code related to the other condition won't get executed or evaluated. Getting back to the code, there's one other thing that's kind of interesting about the optional class I want to talk about. This class has methods that seem to mirror some of the stream pipeline operations. Let me set up a little code to show you this. First, I'll use a stream operation to create a list of strings to get distinct country codes for my list of students. Now, I'll create an instance of optional passing it that list of string. The optional has a map method, so I can transform the value into something else. So here, I'll join my list of strings into a single comma delimited string. Optional has a filter method too, so I'll check to see if the value contains the country code FR. This means if this is false, the value is going to be empty. I'll use if present or else to print either the country code list or the message that FR is missing. Running this code. You can see I get the message, missing FR, because FR wasn't one of the country codes I used. These chained methods look an awful lot like a stream pipeline, but they're not. Because optional is the resulting type of various terminal operations, these methods provide familiar functionality similar to streams for the optional's value. In an upcoming video, I'll show you how to combine the pipeline stream I have here with the optional code as we explore a few more additional terminal and intermediate operations. I'll end this video here with a slide, a word of caution. Some developers took the optional class and really ran with it to try and solve that most common exception, the null pointer exception. It's kind of important to remember that this type was designed to be a return type from a method. You should exercise some caution trying to use it in other situations, for every getter or local variable, for example. Wrapping elements in optional will consume more memory and has the possibility of slowing down execution. Wrapping elements in optional adds complexity and reduces readability of your code. Optional is not serializable. I haven't talked about this yet, but we'll cover serialization when I talk about I/O streams. Using optional for fields or method parameters is not recommended. I'll point you to a Stack Exchange message from the author of Optional if you want further reading. Okay, so now that we know what optional is, let's see how stream pipelines might use it. See you in the next video.